Welcome to Construction Math. Today we're going to talk about how to interpret the slope and y-intercepts of lines. All right, so on your note taker, think about a time when numbers gave you information. Write a couple of them down on your note taker and then share with your partner. Teacher, pause the video and call on non-volunteers, and I'll meet you back here in a minute. Welcome back. Here's some things I thought about. Street addresses, your phone number, the cost of an item at the store, someone's age, their weight, their height. They're all numbers that stand for something in context. All right, so first thing is we're going to have two math checks today. So the first thing I need you to do is find the slope of the line through these 2 points. Teacher, pause the video, have students compare with their partners, and I'll meet you back here in a minute. Welcome back. Let's go to our slate and let's see about how to find the slope. I hope you remember the formula for slope. Remember the formula is, the slope is y2, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Now, the first point was 2, 5. And the second point is negative 3, 10. So let's check out finding the slope. First, I'm going to label these. This is x from the first part, so this is x sub 1. This is y from the first point, so it's y sub 1. This is the second point, so this is x sub 2. This is y sub 2. Now, all I'm going to do is plug them into the formula. What I like to do is put in my parentheses for the formula and then substitute in my numbers. So it's y sub 2, which is 10, minus y sub 1, which is 5. X sub 2 is negative 3 minus 2. So I'm going to do the math. 10 minus 5 is 5. Negative 3 minus 2 is negative 5. So the slope comes out to be negative 1. Let's try the second one. The second one, the points were negative 3, negative 4. And the second point was 5 and negative 3. Again, this is x sub 1. This is y sub 1. These are x sub 2, y sub 2. Remember, these subscripts don't have anything to do with an operation. All right, they're just saying x, y from the second point, y from the first point, x from the second point, x from the first point. So let's now find our slope. I'm going to use the same formula. Again, I'm going to put in my parentheses and then do the substitution. All right, this one would be negative 3. This one would be negative 4. Put in 5 and negative 3. So negative 3 minus negative 4. Remember, with two negatives, it becomes a positive. So that's positive 1. Again, two negatives in a row make a positive, and it's 8. So my slope is, did I do it correctly? Did I copy it correctly? 3 minus negative 4. I got 1/8. So that's my answer. So double check and make sure that you were correct on that. And let's go back to the PowerPoint. We'll clear it out and let's go back to the PowerPoint. And I think I see that I made a mistake. And I did. Down here on the second one, I did make an arithmetic mistake. I left a sign off, or my sign was wrong. I left off the negative 3 in the bottom. So I will fix it, but just know that we were right on the slate. Second thing is for math check 2 is that we need to see what you remember about this item. I drew a pretty nice one on the graph, and what I need you to do is write down as many things as you know about the item below. Teacher, pause the video and give them 2 minutes to write down as many things as they know. Have them share with their partners and then call on non-volunteers, and I'll meet you back here in a minute or two, in this case 2. Welcome back. Let's see what I found. I know it's called a coordinate plane or a graph. It's also called a Cartesian plane for those real math geeks. We have the x-axis is horizontal, the y-axis is vertical, where the 2 crosses the origin, and it's the ordered pair 0, 0. We have quadrants 1, 2, 3, 4. They go from the upper right and they go counterclockwise. That may not be the way that you would have numbered them, but that's the way that Rene Descartes numbered them when he came up with this. Also, they're always numbered with Roman numerals, never with just regular numbers. So I hope you remembered some things about that. All right, so let's go on. Today, the objectives for today are, number 1, define terminology. So the first thing you need to do is fill in the missing terms. Number 2, what we're going to do is we're going to explain the slope-intercept form. And number 3, we're going to interpret the rate of change, which is just another term for slope, and interpret it in context of the data. So it's going to deal with data. I know that in math we deal a lot with just plain old naked numbers, but these are going to have some value and some meaning. So pause the video if students still need to finish, and I'll meet you back here in a minute. Welcome back. All right, here's our first vocabulary words. It's rate of change, because that's probably not as familiar to you as slope. So the definition of rate of change is a rate that describes how one quantity changes in reference to another quantity. And we're going to discuss that further, but I want you to draw a picture, define it in your own words or paraphrase it, and write a meaningful sentence. All right, pause the video. Teacher call on non-volunteers to share their meaningful sentence, and I'll meet you back here in a minute. Welcome back. All right. Hopefully you remember from your Algebra 1 days the slope-intercept equation. It's called y equals mx plus b, where m is the slope and b is the y-intercept. The reason m is called slope and not s is because it's in deference to the French people, and it's an abbreviation for mountain. Now, m is the slope. It's called, if you remember, rise over run. B is the y-intercept. It's where the line will cross the y-axis. So add the missing terms to your note taker, and I'll meet you back here in a minute. Welcome back. So what do you remember learning about slope from algebra? What do you know about it that we haven't already talked about before? So please write it down. Teacher, have students be ready to share with you when you call on non-volunteers. Welcome back. Here's some things that I remember. I remember slope is m. It means rise over run, and there's the formula for slope. It's how steep a line is. And when you get into trig, you can find out actually angles and things like that. But this is the beginning of slope. All right, so now what I want you to do on your slate is draw an xy axis and then draw a line through it that has y-intercept of +1. All right, pause the video, and I'll meet you back here in a minute. Welcome back. Let's go to our slate and see what we can do with this. All right, when you draw an XY axis, do your best to draw your lines as straight as possible. Using this slate is a little difficult for me. So then we're going to make tick marks. And it said I had to have a y-intercept that had +1. Here's where y equals 1. I need to get a line through that. Now there's many choices you could have. You could have drawn a line that looks like this. You could have drawn a line that looks like this. You could have drawn a line that looks like this. As long as your line went straight through this point, your answer is correct, because I didn't tell you anything about the slope. You could have even, if you wanted to, have drawn a line that goes right down through here along the y-axis. Your choice. But it just needs to go through that point. So let's clear off our slates. Let's go back to our PowerPoint. And here's what I need you to do. You have this diagram on your note taker. You have 4 lines: the red line, the black line, the blue line, and the purple line, or the pinkish line. What I want you to do on this is tell me which line has slope of 0, which line has no slope at all, which one has a positive slope, and which one has a negative slope. So teacher, pause the video, have the students complete that, have them share with their partner, and call on non-volunteers, and I'll meet you back here in a minute. Welcome back. Let's see, here's the answer. All right, positive slope is the black line. As you're going left to right, as we read, that line is getting a bigger and bigger y value, so it's positive. Here's the negative one. The y values get smaller as we move left to right. The horizontal line has 0 slope, and a vertical line has undefined or no slope possible. And we'll talk about that a little bit later. But if you didn't get these, make sure you add these to your notes. All right, so here's my line. I'm going to show you how to find the slope and the y-intercept of this line. And since I draw such bad diagrams on my bamboo, I think I'll just go ahead and show you. First thing you're going to look for is you're going to find 2 points on the line. Any 2 points will work. I like to find them when they're at corners or vertices of those little boxes, so they're easier. So I picked the point 0, 2, and I picked the point 1, let's see, 1, 2, 3, 4, 5, 1, 5. So there are my 2 points. All right, I'm going to find the rise over the run. So the rise is 3 and the run is 1. So that gives me my slope, and there's my y-intercept. It's where it hits the y-axis. So here we go. The slope is rise over 1, so 3 over 1 simplifies to 3. The y-intercept is at 2. That's where it hits. And remember, y-intercept is just a number. It's not an ordered pair. So add that to your notes. Pause the video if you need to, teacher, and we'll meet you back here in a minute. Welcome back. Let's have you try this one. I want you to find its slope and its y-intercept. Pause the video, have students compare with their partners when they've gotten an answer, and then call on non-volunteers. Welcome back. Let's see. The y-intercept, oh, it says the y-intercept is +1. That's a mistake. It should say the y-intercept is at +3. Boy, bad typing on my part. Then the rise is 2, and then the run is -1, so my slope is -2. You could have said that the run was +1 if you went the other way, and then the rise would be -2, and the slope would come out the same. It doesn't matter which one you go to. So let's go on. There's my points, and we did it. Now we're going to talk about rate of change. Rate of change appears all the time in real life. You probably just never thought of it. But 40 miles per gallon, that's a rate of change. If I spent 59 cents per can of tomatoes, that's a rate of change. $7.80 an hour, $7.80 per hour is a rate of change. If a -10 gallons per 2 hours, that means I use 10 gallons of gas every 2 hours. So on your note taker, write another rate of change. All right, compare with your partners, teacher call on non-volunteers, and I'll meet you back here in a minute. Welcome back. All right, now in rate of change, units are what's going to help us understand the rate of change. For example, if I bought 4 cans of tomatoes for $2, we're going to find the rate of change and tell us what it stands for. In this case, it can be either way. So I picked by putting 4 cans over $2. Now you could leave it that way. You could simplify it to 2 cans over $1, or you could even simplify it to 1 can over 50 cents. Now if you switched it around, $2 per 4 cans, that would have been fine. There was no context for this as far as which one was the X and which one was the Y. So now here's an example. Bill had 5 gallons of gas in his motorbike. After 100 miles, he had 3 gallons left. We want to graph it. We want to talk about its slope or rate of change. We want to find the y-intercept. But more importantly, we want to talk about what that means. So on your note taker, add the missing number values to your note taker. We'll go on. So now I want you to find 2 ordered pairs, graph the ordered pairs, and draw a line through them. All right, you have a graph on your note taker, so go ahead and use it. Teacher, pause the video, have students do that, and then compare with another group of partners. I'll meet you back here in a minute. Welcome back. All right, here's my graph. I never went into negative because I didn't know what negative gallons meant, and I don't know what negative miles traveled meant. But I picked one of my ordered pairs was 0.5. If I've driven 0 miles, I have 5 gallons of gas. And then at 100 miles, I only had 3 gallons of gas left. So here's my graph. Yours may look similar, hopefully, to mine. If not, go ahead and plug those values in and graph it. Now, here's the information. Now I found slope from 0.5 to 100,3. I found the run was -100 and the rise was 2 gallons. All right, because we went 100 miles, I rose 2 gallons. I could have gone the other way and said the run was +100 and the rise was -2. Either way, you're going to get 1 gallon, a -1 gallon for 50 miles. What that means is that the negative means I use up 1 gallon of gas for every 50 miles I drove. Now the y-intercept at 0.5 means at 0 miles traveled, I still have 5 gallons of gas in the tank. So I use those labels. All right, pause the video if you need to discuss this further, and I'll meet you back here in a minute. Welcome back. Now, here's one for you. Fill out the chart on your note taker. It said Owen collected data about the relationship between the number of amps, the volts, and an unknown resistance, and he got this. On his volt, he found out that he used, if the amps were 0.06, the volts were 3. If the amps were 0.09 amps, you had 4.5 volts. If the amps were 0.12, then you had 6 volts. So fill out the chart with those missing numbers, and I'll meet you back here in a minute. Welcome back. So let's see. Use the data to find the slope. All right. So pause the video, teacher, and have the students use this data to find the slope. All right. Now, what we're going to do is we are going to go to our slate when you're ready, and we're going to find the slope. I have 3 values here. I have the order pair 0.06. These are amps, comma, and I had, let me read it again. I had 3. I'm sorry. I needed to just read the number 3 again, and that's volts. The second point was 0.09, and he had 4.5 volts. The last point was 0.12, and he had 6 volts. So it doesn't matter which point you take. You can take either. I think I'll take the first and the last just to be a little bit different. Well, this is a y sub 2. So here we go. So I'm going to take y sub 2, which was 6, subtract y sub 1. I'm going to remember that these were volts. I'm going to take 0.12 and subtract 0.06, and I'm going to remember that these were amps. So I'm going to do the math. I come out with 3 volts over 0.06 amps. I'm going to do the math, and I'm going to come out to be, if I did it correctly, I think it's 50. Yes, so it would be 50 volts over 1 amp. Now, if you're really into electricity or your teacher has taught you, volts over amps reduces to ohms. So this would be 50 ohms, and the abbreviation is 50, and this is the symbol for ohms. Now that's what it would say on the resistor. The resistor would actually be 50 ohms. You would have gotten the same answer if you'd have taken these 2 points, and the same answer if you would have taken those 2 points, or the same thing, these 2 points. So it doesn't really matter. All right? So copy that down into your note taker. Pause the video if you need to, and I'll meet you back here in a second. Welcome back. Let's go to our PowerPoint. And then think about, there we go. And now, what does it mean? What does the y-intercept mean? All right, so here's how we find the y-intercept. So I'm going to give you a chance. Let's go to my slate instead and see what we can do. All right, so the first thing I do is remember that the formula of the line is y equals mx plus b. I just found that the slope or the resistance was 50 ohms. Okay, so I'm going to put 50 in place of that. Now, I've got to find one of those 2 points. So why don't I use the point 0.12, comma 6. This is the x point, this is the y point. I'm just going to plug them in. So I get y is 6, x is 0.12 plus b. 50 times 0.12 is 6. Subtract 6 from both sides, and I get b is equal to 0. Now, what does that mean when the y-intercept is 0? Remember, that's where it hits, right here. X is 0, y is 0. And what it means is, remember that these particular values we had, double check, that the y was the volts and the x was the amps. So that says that when we have 0 amps, we get 0 volts, which makes sense. If we don't have any amps, we're not going to get any volts. That's what it means. We're just going to use the labels. So let's clear this out, go back to our PowerPoint, and here we go. Got the same answer, and it means when there's 0 amps, there are no volts. Now, here's another example. All right, collected data about the slope of a roof. He recorded that 12 inches of run had a 9-inch rise. He recorded that 36 inches of run had a 27-inch rise. So what I'd like you to do on this particular problem is, would you graph it on your note taker first? All right. They should already be set up for you, and all you have to do is graph the points and then draw a line between the points. All right. So let's go ahead and look at our graph. We're going to find the slope. We're going to tell what the slope or rate of change tells us and what the y-intercept means. Those are our goals. So here's the first. Here's my graph. It's a little prettier than I could have done on the just on the slate. So I've got 2 points, 36.27 and 12.9. Let's go ahead and go to our slate and go ahead. We had the points let's get back over here. 36.27 and the other was 12.9. Doesn't matter the order. I'm going to show you. I'm going to make this x sub 1 and this y sub 1. I'm going to make this x sub 2 and y sub 2. I'll get the same answer. It doesn't matter, as long as I plug them in the right place. All right, so y sub 2 is 27. Y sub 1 is 9. X sub 2 is 36. This is 12. If you have them reversed, only the signs will be different. This gives me 18 over 24. Right? And so this would be 3 divided them both by 6, 3/4. So my slope is 3/4. What does it mean? Remember, this is rise, this is run. So there's my slope. For 3 inches of rise, we're going to have 4 inches of run. All right, let's go back to our PowerPoint and see if that's what the picture looks like. If I went over 3 units, I'd go up 4. Looks pretty good. Now, the next thing I wanted you, here's my slope, 3 inches of rise, 4 inches of slope of run. There we go. Now the y-intercept. So I'm going to stop this for a second. All right, now we just found the slope. Now we want to find the y-intercept. So let's go to our slate and find out. Our slope was 3/4. And let's find one of the points. Let me get one of the points was 12.9. Doesn't matter which one you pick. Either one will give you the right answer. Here's my formula. Y equals mx plus b. This is x. This is y. I'm just going to plug it in. So 9 equals, my slope is 3/4. My x is 12 plus b. Remember, when you multiply fractions, you make them both fractions. 4 goes into 4 once, 4 goes into 3 times. So I get 9 equals 9 plus b. Subtract 9 from both sides. So 0 equals b. So the y-intercept is 0. All right, so it would be right here. Remember, on my x, this was the run, and this was the rise on my roof. So it tells me that when I have 0 run on my roof, I have 0 rise. In that case, it would be just like a straight line. But that's what it means. All right, so let's clear this out whenever you're ready. Let's go back to our PowerPoint and let's check. Here we go. There we go. We found the same one. So if my y-intercept is 0, it means 0 run, 0 rise. And there we go. There's the answer. Now pitch. There's something in construction, and I'm sure your teacher has talked to you about it. Pitch is a special kind of slope. It's the slope where the denominator or the run is always 12 inches. So you'd say something like, we have a 4/12 pitch, which means if you run 12 inches, it rises 4. You can have a 3/12 pitch, and I'm sure your teacher will talk more about that with you. And so today, for your test drive of your closure, write a tweet to a friend or an absent classmate using 140 characters or less to explain what you learned about this lesson. Teacher, call on non-volunteers when you're finished, and I'll meet you back here again for another construction math lesson.